One of the earliest signs that climate change is affecting the biosphere came from phenology. Advance in the timing of green up in the spring, delays in the time of fall senescence in the fall. These are responses that can occur quickly because they're responding to changes that in climate that are occurring right now in the same season. Those are important to ecologists because if we lengthen the growing season through advanced budbreak, for example, there can be a longer growing season in which carbon, CO2 from the atmosphere can be withdrawn and stored in plants and soils. So that's an early and quick response to climate change that could be important for the whole planet. We can see that this pattern is going on from space through satellite data, but that doesn't allow us to relate that to individual species, for example. Which species are responding to climate change? For that, we have to have observations on the ground. Tong is going to take us into the field with Rob and Haley. He's going to show us how to collect citizen science observations on phenology. We'll come back at the end and relate that to the vignette on using the citizen science data.
Welcome to this virtual lab, everyone. I'm here with Tong, and we are going to together walk you through understanding phenology and helping with citizen science. There's a lot to it. Okay, let's get into it. Phenology is like a fancy science term.
Yes.
And like nobody else uses that, right?
Yeah. If you take a walk around the field, you can see the colors of the leaves are changing colors from green to brown, red. So that's one component of phenology, which is foliage coloration. And then there will be other key components like spring leaf out, and then summer peak, and fall senescence, and also winter dormancy. So those 5 components will make up the phenology. So I study phenology, I study biodiversity using different sources of data, such as remote sensing and citizen science data. Biodiversity is kind of my thing. So I always loved Mother Nature in my childhood. So that's why I pursued to study this path. So I was like 3 or 4 years old. So I went to hiking with my parents and then see the beautiful vibrant colors of red, brown, and yellow. It's foliage coloration. But back then I don't know what is that. So which makes me very interesting. So why the leaf is changing colors in the fall. Yeah.
Then Tong sat down with me and showed me the data of how climate change is related to phenology.
Yeah, so on the left we have the linear trends of spring mean air temperature from in the northern hemisphere from 2001 to 2017. Mm-hmm. So red colors means temperature is getting higher, blue colors mean temperature is getting colder. So the majority of the northern hemisphere is showing warming trends, mm-hmm. especially for the higher latitude. Mm-hmm. On the right we have phenology metrics derived from satellite remote sensing. So we already define a spring onset, like the start of the season.
Right.
And then we calculate the linear trends from 2001 to 2017. Red colors means spring season is earlier, and blue colors means spring season is later. So we can see those spatial patterns match with each other. When the temperature is increasing, the spring season is earlier, and the fall season is later. So that's what we found from remote sensing data.
Most of the time, you're doing this with remote sensing?
Yes.
And then why can't you use remote sensing all the time? Why do we need...
Good question.
A big part of this is citizen science.
Yes.
Why even have citizen science?
Very good question. So the thing is, to understand why phenology can be limited, we need to understand the concept of spatial resolution. Remote sensing is just like the Earth is trying to take selfies from the space. And then, there will be the smallest object that the sensor can detect is the spatial resolution. For example, if we have a spatial resolution of 500 meters, which means anything smaller than 500 meters cannot be detected with remote sensing. Mm-hmm. So for example, this stand we have a variety of species like red maple, oaks. So there will be one single pixel on the remote sensing image. So we cannot reveal those variations across the stands.
And that's important because why?
Because different species will respond to different degree to warming. Which means red maples maybe 15 days, and then birch maybe like 10 days. Uh-huh. Yeah, we need that. We need species level information.
We're just trying to figure out what's happening so that we can put it into models.
That's right. We can put it into species level models. The species level model is very important for biodiversity. So like competition between different species. If these species have an earlier spring, like 10 days, it means it can have more resources, like may allow it to compete with other species. So for phenology, we need those data repeatedly. So you have to repeat the same site, same tree, same species, twice a week or sometimes once per day to get accurate observations. Because the color changes really fast. Today is green and tomorrow may be yellow, and the day after tomorrow may be already red. So you have to track those changes repeatedly.
I feel like I understand it now. And this is where we get to the citizen science part. How can people help collect this data?
So people can do that in their backyard, so they don't have to travel a lot. So just go to their backyard and take the observations, and then repeatedly across the week. First thing you can do is download some field guide in your state, so where you can check some native species. The second thing you can do, there are some apps on the internet. You can just take pictures of the leaves and then using some artificial intelligence to identify the species. Sometimes the predictions are horrible, but sometimes if you take enough pictures, it should be fine. Yeah, and always identify the species you are confident in. So we don't want to mess up with the results for the database. Yeah.
Finally, I wanted Tong to walk us through exactly how you collect the data on the app.
So first we're going to go to Nature's Notebook,
Okay.
which is an app you can download from Apple Store or Google Play Store. And then the first thing you're going to do is to register for your account. So here I already registered for my own. So it's very easy. You can just type in your email account and then they will send you an email to your inbox. Click on the link and then activate your account.
So you have to do that before you go out in the
Yeah,
field.
before you
But
go to the
other
house.
than that, then
Yeah.
you can be remote. Okay,
Yes, that's
good,
right. That's
good.
right. Yeah. And then the next thing you're gonna do is click on this button. There'll be a create site, and you want to create site that you have accessible into like your backyard. And this site you will go there frequently, twice per week or sometimes once per day during some peak season. So that's very important.
Okay.
And then next you're gonna do is you can go to your plants and animals. So here, since we're at Mountain Lake Biology Station, so I have plot 1. So go to plants and animals. So here you can identify many species. The thing is you need to limit the number of species you are trying to observe because you will be there each day or twice per week. So it's the matter of repeated observation, not the number of species.
All right. It's
Yeah.
not just about saying what's here. It's you're actually trying to get data over time.
That's right, data over time. Yeah.
How many should people input?
So I think 2 will be enough. 2 or 3 will be enough
Yeah,
for the
okay.
species. Yeah.
All right, good.
And you can also choose multiple plants for the same species. That's what you like. Yeah. But yeah, here I just use 1 for each species. So and then you can add plants or species here using this button.
Okay.
And then now you can just go to observe, which is a red corner. And here, so today you have an observation date, which is very important. So here we have September 30th. And then you can select which species you want to observe. So
Okay.
here I have 3 species. And then those will be the phenophytes you have. If you see the difference like breaking leaf buds, leaves, increasing leaf size, color leaves, falling leaves, flowering, pollen, fruits. So that's what we get.
Okay.
And then there will be 3 buttons: yes, no, and uncertain. So if sometimes you didn't see any leaf buds, like in winter, so you can just mark all phases as no. So this will get all so we didn't observe any of the signals.
All right.
And if you see the breaking leaf buds, you can just type in yes, and then there will be a new window pop out asking for the intensity of how many buds on the tree are breaking. So that's what they get. So you can use your binocular to look at how many buds are breaking and choose different numbers here.
And that's per tree?
Per tree.
So you have to estimate how many buds on the entire
On the entire tree.
tree.
Yes, that's right. For the same species, yeah. And then if you are not,
No, but I guess you would take like one branch
and then multiply by
and then
that.
you would be like, okay, there's 15 branches, and then so you do a little math.
That's right, yeah.
Alright, that makes
Multiply by the number of branches. And if you are not sure, so what is the breaking leaf buds for this species look like, there's a little tip here. Like for Cocos alba, leaf tips may appear reddish. So that's kind of like this.
Okay.
And then if you are not sure about what phenophase it is, or you are not sure if that's a breaking leaf bud, you can click on uncertain. So that's not
Doesn't
sure.
get-
Yeah, that's
okay.
right. So, and then for the leaves, they are just the same. So just different stages of phenology.
Of different ones.
Yeah.
Click the leaves one. Say yes, leaves.
Yes, leaf.
Oh,
be
okay,
like-
so it
yeah.
doesn't make you count the leaves.
Yeah, the leaves is hard to count.
Just give you a percentage of how many are there.
That's
Okay,
right.
That's good. All right.
Yeah.
Okay, that seems pretty straightforward.
Yes.
So you will have to use some math, and so especially on things like the fruits, you're going to have to use some math too, right?
Yes, that's right, for the fruits.
You would actually have to count how many seeds are on the tree.
That's right. Yeah. Yeah.
Okay. Now, just to be clear,
Uh-huh.
like you on your nature notebook, you have 3 species. You have
Yes.
the white oak, the red oak, and a maple.
Yes, that's right. Southern red. Yes.
Now, you need to go back to that individual tree.
Yes, the same
not
tree.
The same tree every
Yeah.
time, not just a tree of that species.
No, you have to go to the same plants every time you go. Yeah.
So that's a quick summary of how to take phenology data and why it's important. It is 44 degrees and we are cold, but Tong's doing really well, and he's borrowing my sweater.
Yeah. Thank you so much, Rob.
I hope you're able to get out into the field successfully, identify a few trees, and track them over time. Now here's a few extra words by Dr. Clark.
Phenology, or the seasonal timing of events, is very important for species interactions. Pollinators depend on the time when flowers are available, the time of year. Leaf feeders may really depend on when young succulent leaves first become available and before those leaves are heavily defended with chemicals and lignin against those leaf feeders. Seed production and fruit production can support seed dispersers, seed consumers. The timing of those events can influence how the consumers respond. As climate shifts the timing, seasonal timing of these events, it can disrupt food webs and have influences that ramify throughout natural communities. In the vignette that goes with this unit, you'll have a chance to see how the observations that Tong described can be applied to some of these scientific questions.